Okay everyone, this is section 6.1. In this section here, our goal is to be able to evaluate nth roots in rational exponents. So some vocabulary here: the nth root of a for an integer n greater than 1. If b to the nth power is a, then b is an nth root of a. And we typically write this as n, or nth root of a, where the index, which is what we're going to talk about next, is going to be on the outside. That represents our n. So that same index n, think of it as a power of whatever it's equal to, and it should get back to what's underneath your radical, or in the radicand. Okay, so that index of a radical, again, is just some integer n that's greater than 1 in the expression the nth root of a. Okay, so it's always going to be some kind of number bigger than 1 on the outside of that root. So let n be an integer greater than 1, and let a be a real number underneath the radical. Okay, so n again is that index on the outside. If n is an even number, so if it's an even number on the outside and your number underneath your radical is less than 0, then you're going to have no real nth roots. Okay, it's going to evaluate to no real nth roots. If your a is exactly 0 underneath that radical, there's only going to be one real nth root. So the nth root of 0 is exactly 0. But what if your a is greater than 0 underneath the radical? Well, there's going to be two real nth roots, and that's where we're getting that plus or minus as your answer. So your plus or minus is the same thing as a to the 1 over n. So these can always be rewritten. Okay, so let's say I had the third root of x. Okay, if I rewrite this as a exponent, these are always going to be fractions. So we haven't had fractions as exponents up until this point. Okay, think of it as the inside, you have a 1 as an exponent on that x, so it goes on the top. Okay, or in your numerator. But your index is going to go in the bottom, or you're in your denominator as your fractional exponent. Okay, so what if we had, let's say, b to the 5th underneath the radical, but it's the fourth root of b to the 5th. Well, our base is b, the inside exponent was 5, so it's going to go in the numerator, and your index was 4, so it's going as a denominator. So I rewrote that as b to the 5/4. Okay, and what if we had just regular square root of 3? Okay, again, we can assume on the inside of the radical I have an exponent of 1. I just can't see it. But there's nothing on the outside, or as an index this time, on the outside of your root. If you do not see a number or index on that root, we're assuming it's a 2, because we say the square root of 3. Okay, so if you don't see any index on the outside of that root, assume it's a 2. And if I rewrite that, that's base of 3 to the 1/2. Same thing if you just had a variable, like the square root of y, let's say. Well, I don't see any index on the outside, so I'm assuming it's 2, so y to the 1/2. And there we go. So this was just talking about if your index is even and it's greater than 1, and talking about the circumstances of what's underneath your radical. Is it less than 0? Is it equal to 0? Or is it greater than 0? But what if your integer on the outside as your index is odd, and a is some kind of real number underneath your radical? Well, if a is less than 0 underneath that radical, then there's still going to be one real nth root. If it's equal to 0, then there's still one real nth root, so the nth root of 0 is still 0. Okay, and that could be true, like the third root of 0 is still 0. Okay, 3 in this case, the index is odd, so it's still 0. And what if your a is greater than 0 underneath that radical? Well, it's still the same thing. Okay, you got one real nth root. So in example 1 here, we're going to find the indicated real or nth roots of a. Okay, so in this case, n is 3 and a is negative 216. Well, my n is odd, okay, and my a is less than 0. Okay, so my n is odd and my a is less than 0. So when we go to do that, since my n is odd, or my index is odd, if we rewrite that, and my a is less than 0, according to what we just talked about, we're only going to have one real nth root. Okay? So we're going to have one real nth root. So when we type this in the calculator, the third root of negative 216. So what we got to do is hit math, and you'll see at number 4 and number 5 there, the third root and the nth root. Number 4 is if we have anything with the index of 3. Number 5, we're going to press if we have to have any index of 4 and above. We can put in our own index there. But since we want the third root, I'm just going to hit number 4, and we're going to put in there negative 216. And we get back negative 6. So the third root of negative 216 is negative 6. That's our one real nth root. Or we can rewrite this as negative 6 is equal to, let me see, negative 216 to the 1/3, if we rewrite that radical, is equal to negative 6. They mean the same exact thing. Now let's look at b. Well, n in this case is even this time, and a is greater than 0 because it's 81 now. So if we do this one, the fourth root of 81, well, according to what we talked about before, if we have an index n that it's even, and our a underneath that radical is greater than 0, we're going to have two real nth roots. So we're going to have that plus or minus in there. Okay, so we know we're going to have a plus or minus because we got the positive case and the negative case. That's where we're getting 2. If I hit math, and I want to hit number 5 this time because I'm going to put 4 as an index on the outside. And then tab over to the right to get 81 in there. And we get back 3. So our two real nth roots are positive 3 and negative 3. And this is the same case. 3 will get there by rewriting 81 to the 1/4 power. Is still positive 3 or negative 3. Okay, and still kind of the same case. If I use negative 6 from that first example and raise it to the 3rd power, which is the same kind of index, okay, that I used on that radical, I'm going to get back negative 216. Same thing applies down here. If I raise regular 3 to the 4th power, I get back 81. And if I use negative 3 to the 4th power, I get back regular 81. Okay, so see the relationships between fractional exponent and radical form. I could just rewrite those back and forth, and I can use whatever we get as an nth root, raise it to the same kind of exponent as the index you had, and you can get back what you got underneath your radical. Okay. Rational exponents. Let a to the 1 over n be the nth root of a, and let m be a positive integer. So this is what I was talking about before. If I have a to the m over n, I could just split them apart and move m to the outside. Because when I distribute here, I get back m over n. Or this is the same thing if I just rewrite it as radical form. Okay, the nth root of a raised to the m. Same thing applies if I have a negative fractional exponent, negative m over n. Okay, just flip it to the bottom because that's what fractional or that's what negative exponents do, is we flip them to the bottom because they were negative. Excuse me. And then split them apart. Because again, if I distribute here, I'm going to land back with m over n. And then I'm just rewriting this part as a radical raised to the mth power. So let's try some of these. We're going to evaluate the expression using roots, okay, and or fractional exponents. So 16 to the 3 halves. Well, let me just write this as 16 to the 1 half raised to the 3, because again, if I distribute that 3 to the 1 half, 3 times 1 half is 3 halves. So all I did was split them apart, took the numerator and pulled it out. Then if I evaluate what's in the parentheses, 16 to the 1 half in your calculator, that's 4. And it's still raised to that third power on the outside, but 4 to the third power is just 64. So here we go. And we could even switch that up a little bit. What if we did, well, if we took what's inside the parentheses and just rewrote it as a radical, a square root of 16 to the third power. Well, we know the square root of 16, that's 4, raised to the third power, which is still 64. So we got the same exact thing, whether we write it in fractional exponent form or the radical form. Same thing applies if we do 32 to the negative 3 over 5. Okay, so let's start out by writing it in fractional exponent form. Well, since I have a negative fractional exponent, I'm going to write it over 1 and drop the negative, because I already flipped it. Then I'm going to pull it out, or pull the numerator out. So I'm going to leave it as to the 1/5 raised to the third. And then I'm going to evaluate what's on the inside the parentheses. Well, 32 to the 1/5 in the calculator. And again, let's review how to do that. So 32 exponent alpha y equals, because we've got to make a fraction, 1/5. Well, that's just 2. So this is now 2 to the third power. Well, we know 2 to the third power, 1 over 8. So there it is in fractional exponent form. Now if we redo it as a radical part, well, we're still working with 32 to the 3/5 after we flipped it over from being negative. Then if I rewrite this as a radical, my index is 5 now, since it was in the denominator of 32, but that's all raised to the third power. Okay. Then same thing, if we put this in the calculator, the 5th root at 32, that's 2, raised to the third power, we can't forget that. Well, it's the same thing as 1 over 8. So no matter how you write it, fractional exponent form or with the radical, you'll still end up with the same kind of answer. In example 3 here, we're going to approximate these roots with the calculator now. So now we're going to do 9 to the 1/5. Well, we can do that in the calculator. We need 9 exponent alpha y equals to the 1/5. And we get back 1.55, and if we round it to the 1,000th, 2. So 1.552. B, we're going to do 12 to the 3/8. So 12 exponent alpha y equals 3 over 8. And if we round that to the 1,000th, 2.539. So 2.539. And see there, now we're going to do a root one. So the 4th root of 7 raised to the third power. So first, what I want to do is a parenthesis and hit math and number 5. So we could put our own index out there. So we need the 4th root of 7. Then tab to the right to get out of it and put a parenthesis there. And then raise it to the third power, or exponent of 3. And if we round it to the 1,000th, 4.304. So we're going to have to rely on the calculator for certain kind of roots and fractional exponents to approximate these types of roots. In example 4, we're going to actually solve something this time. So we're going to solve for x, given 4x to the 5th is equal to 128. So our first instinct is still to get rid of that 4 first. So what we're going to do is divide both sides by 4. So we get x to the 5th, and 128 divided by 4 is 32. But now we got to get rid of that 5 as an exponent. So we're used to saying, okay, if we got x squared equals 4, well, to undo that power of 2, we take a root, and we end up with 2. We're going to do the same kind of thing, but we're raising it to the 5th root of x to the 5th, because they undo each other. Okay, so this time we're left with x, and we can put in the calculator the 5th root of 32. That's just 2. And since if we go back to what we talked about at the beginning, our index n is odd, and our a is greater than 0. So since our n is odd and our a is greater than 0, we have one real nth root. And we've seen that to be 2. Okay, so here's our answer, just plain old 2. And our last example here, example 5, we're going to do the same exact kind of thing. So we're going to solve the quantity x minus 3 raised to the 4th power is supposed to equal 21. So the first thing I can do is get rid of that 4th power. I can't move the 3 over, I can't do anything like that because it's underneath an exponent of 4. So what I could do on both sides is raise both sides to the 4th root. Okay, so that they cancel each other out, the power of 4 and the index of 4. So I'm left with x minus 3 is equal to the 4th root of 21. And before we evaluate that, let's think about what kind of answer that would be as a root. Okay, so in this case, our n is even, and our a is greater than 0. And what we talked about at the beginning, well, n is even and a is greater than 0, I should have 2 real nth roots, which meant that I had that plus or minus in there. Okay, so what I'm going to do is add that plus or minus to the front of that 4th root of 21. And it's not quite perfect, so I'm going to hold on to it a second, because I still got to solve for x still. I got to move that 3 over. Okay, so I'm going to be left with x equals plus or minus 4th root of 21 plus 3. Okay, and when I evaluate those separately, let's evaluate them each one separately. So if I use the positive case, a regular 4th root 21 plus 3, and the negative 4th root of 21 plus 3, okay, we're going to put these in the calculator. So if I start with the positive case, so math number 5, because we want the 4th root out there, of 21, and then tau to the right to get out of the radical, plus 3 is 5.14, we'll say. So here's our positive case. Then the negative case, so we need the negative math number 5, because we need the index of 4 on the outside, of 21, tau to the right to get out of the radical, plus 3 is 0.86 if we round. So about 0.86. Here's our approximate roots. There's 2 of them because our n was even, or our index was even, and what was underneath our radican was bigger or greater than 0.